Okay, so we talked a little bit yesterday about accuracy mattering. It's frozen, so you can't see it. Let me unfreeze it. So I want to briefly hit on that really quickly. So you know what this is supposed to look like. If I say sketch it, you would sketch it, right? But if I were to check it, I'd say, okay, I know it's a parent graph, so I know it's going to start at the origin at 0, 0. I know it's supposed to look like this. Well, let's test something. Let me put in 5. So if I go over, if I put in 5, y equals the absolute value of 5, I would get 5. So over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. Well, I know it should also be symmetrical, right? So if I put in negative 5, I should also get 5. But I'm just going to check. Is the absolute value of negative 5 5? It is indeed. 1, 2, 3, 4, 5. So if I put in negative 5, I'm going to get 5. The same thing goes with something that's squared. I know it's supposed to look like this, right? Let's change my color. I know it's supposed to look like that. Well, let's test it. I know it's supposed to start at my vertex is 0, 0. Let's test 1. Y equals 1 squared. 1 squared is just 1. Well, if I were symmetrical and I put negative 1 in there, I would also get 1. I think I've got it all handle on it, but let's try 4. What if I put in, let's just try 2. 3 is easier. You can see it better. 1, 2, 3. If I put in 3, what do you think I'm going to get? 9. So it should be symmetrical, and I should get the same thing on the other side. Let's double check. Y equals, if I put in 3 for x, negative 3, squared, I'm going to get positive 9. So I did it correctly. Let's try it with this one. Let's put in, okay, where am I going to, it's a parent graph, so obviously it's going to be at the origin. Let's see. If I put in 2, what do you think I'm going to get? 8. 1, 2, up 8. If I put in negative 2, what am I going to get? I'm going to get negative 8. So it's going to look like that. This one is not the parent graph, but I know what the parent graph looks like. The parent graph is supposed to look like this. And I say to myself, Mrs. Mahler talked about how that 3 can be brought out in front and talked about kind of like slope, right? Or our scale factor. Well, I know there's no horizontal shift because it doesn't say x minus something. So it really looks like this. 1 over x minus, there's no shift, right, horizontally, and there's no shift vertically. So I have a 0 out there. All right, the only thing is that scale factor. So I say, I think it's over 1 and up 1, 2, 3. Or up 3 over 1. Well, let's check and make sure. If I use the original equation, I'm going to do that and bring it down a little bit. If I use the original equation, I would say to myself, y, need a pen, y equals 3 times 1 over, what did we put in? For x, what did we put in? 1. So what am I going to get? 3. So was I correct? And I think Mrs. Mahler said something about I could go up 3 over 1, or I could go over 3 and up 1. Isn't there also a point supposed to be there too? Well, let's check. Where was that on my x-axis? How much did I go over? I went over 3. Let's check. Y equals 3 over, I'm going to substitute 3 in for x. What do I get? 3 over 1/3 is 1. 3 over 3, which is 1. So was I correct? I went over 1, and I went over 3, and I got 1. So I am correct. So before, so I must be able to do that in the other one. Go over 1, down 3, go over 3, up 1. So the whole point of this discussion is that we've been sketching, right? Now we're going to use what we know about behavior of graphs and parent graphs and family of graphs, right? To be able to sketch new graphs. But now things are getting a little more complicated, so we're going to have to test points every once in a while to make sure we're on the right track. Okay? I would much rather you know what it's supposed to look like than just plot something. Here's my reasoning. Somebody can make a table, a fancy table, right? And just start getting points. And then they go, I think it's one of these. Yeah, it looks like that. Right? If they knew family of graphs, they'd know that couldn't possibly be correct. My math must be wrong in my table because my sense of math, when I think about it and reason through it, tells me that this should look like a V. So my math must be wrong in my table because I know what this graph is supposed to look like. That's where I'd rather you be. Okay? So that's what's most important. Understanding what it's supposed to look like, number 1. Being able to plot points and see if you're correct, number 2. Okay? So that should look like that. All right, so let's use that. Let's use everything you know about family of graphs, how we've learned how transformations work with graphs to move forward today. So yesterday we finished off with this last part of our discovery, right? We realized that if we took and reflected over y equals x, we got a parabola that was like tilted on its side, right? But if this was my original function, and this is technically its inverse, it's really not a function right now, right? It's really not a function until I decide that, I've got to erase it. I forgot. I grouped it. It's going to take me a quick second. Ungroup it and erase. I need to get rid of this part of it. I think I did. I made a big old mess. I still have that part, and now I can erase these. Perfect. Okay. So now that I erased it, I think what I was trying to get at the very end of class was this part of my graph right here. This is called a square root function. So originally we had y, let me do it in blue. Originally we had y equals x squared. And when we transpose x and y, or switch their roles, we got this. Well, I have to solve for y when I graph. So I took the square root of both sides, and I got x equals, the square root of x equals y. Or f of x is the square root of x. That's my inverse function. I should be writing inverse. Inverse function. So what we're doing is we're seeing the relationship between a quadratic function and a square root function. They're like buddies. They have a direct relationship, right? The square root function is just the inverse of the quadratic function. It's only a piece of it because it wouldn't be a function with the rest of it. And I think the last thing we were talking about yesterday was which part of this graph would I have to erase in order to get that square root function right there. I think we decided on the negatives, right? Because this is the negative part of the graph, and this is the negative part of the graph. So technically when we're doing this, and you don't have to write it, this is just for informational purposes, when I'm trying to find the inverse I would say the domain of this, we'd have to say that x has to be greater than 0 on the blue part, right? We're only talking about this part of the graph. We're just going to take the inverse of this part of the graph, then it's going to flip over that y equals x, or reflect over it, and we're going to get that part of the graph. So in reverse, if we took a square root function, and I said take the inverse of this square root function, would you get the whole parabola? No, you would just get the part that's on the right-hand side. Okay, so hopefully that'll help you with your discovery today. I really think it will. So here's your discovery. I just want you to do 1, 2, 3, and 4. Okay, so go on Desmos, and I want you to graph f of x equals x, f of x equals x plus 2, or quantity x plus 2. This is f of x equals square root of x plus 2. You see the difference between those two? This is the quantity of x plus 2. This is the quantity of x plus 2. This one's the quantity of x minus 2 minus 2. Okay, so look at those relationships. Talk amongst yourselves if you want. I'm going to give you 5 minutes to go ahead and finish that. Okay, so we should have all seen that with our parent graph of our square root function, we're always going to be just like the other graphs at 0, 0. Then what happens? It makes a curve. Good. Okay, can you guys tell me if I go over 1, how many does it go up 1? How many does it go up? If I go over 1, it goes up. Thank you. And if I go the next point, so I'm going to double check. So if I put in a 1 underneath an absolute, a square root sign, I get 1. Right? So would I put a 2 in next? No, because that would give us something, but it's a decimal. So the next easiest one would be what?
4.
A 4. If I put a 4 in, I get 2. So 1, 2, 3, 4, 1, 2. That's all you need. That's all you need to graph these. Okay? Square root of functions. Okay, so here, let's do another one. So did you notice anything different on this one? Did I start at 0, 0? Where did we start? Negative 2, but that says positive 2. It's the opposite. I wonder where we've seen that before. It's not squirrel in this case. Okay, let's keep going. I'm going to pretend like I'm over back at the parent function. Okay? I'm going to forget the fact that I shifted over 2. And so I know my square root functions really well. Right, Angie? I know them really good, and I know, well, if I put 1 into a square root, I get what? 1. And if I put 4 into a square root, I get what? So if I go over 4, 1, 2, 3, 4, and up 2, let's double check. It just went out on me. I just switched these. 1, 2, 3, 4, 1, 2. 2 ways I could check. I could use whiteboard magic and do this. It's the same thing, only shifted over 2. It's the exact same graph. It's just shifted. It's translated to the left 2 units. Correct? So what do you think this one's going to be translated? So some of you, I hear down, left, up, I hear all of it. Okay, so when we're uncertain, what should we do? Desmos, what if you don't have Desmos? It's in a test. What if it's a test and you're unsure of which direction you're going to go? I don't really like plug though. Substitute in a point, right? Substitute in a value for x. So what do you want to set? What do you guys think? I want to know where the vertex is, guys. I want to know where it starts. So you guys all think it's going to start here? All right, most of you are saying it's going to go up 2. Okay, let's check. Let's see if we're right. Okay? So I'm going to say, I'm going to substitute a value of 0 for x, right? I'm not going over on the x at all. I'm staying at 0. Well, if I put in 0 into the square root, it's just 0, right? So don't I get 2? So when I put in 0, I get 2. Okay, now let's use what we know about square root functions. Normally, on a square root function, when we go over 1, we go, what? Up 1. Let's double check that point. If I go over 1, I should get an answer of 1, 2, 3. Let's put 1 in there. Do I get 3? Well, the square root of 1 is just 1 plus 2 equals 3. So I'm correct. Okay, let's be fancy, Sina. Let's be fancy. I'll get to you in just a second. So before I went over 1, up 1, and then what was the next value we chose for x? What do we plug in? 4. So if I go up over 1, 2, 3, 4, I'm probably going to have to go up 2. It's going to be the same shape, right? Let's check. If I go over 4, then I should get a 4. If I go over 4, then this would be 2 plus 2, which equals 4. So all you really need to know is what the shape looks like and how it's going to now. So ask yourself, what's this going to look like in your head? And then I'm going to graph it. Everybody look at it and try and visualize, not on your paper, Linzo, up here. Let's see what it's going to look like. I'm going to take this guy, and I'm going to say to myself, you guys ready? You already have a visual of what it's going to look like? I look at this and I say, this is a horizontal shift to the right 2 and 2 down. That's what it's going to look like right now. Okay, Sina, what was your question? No, we start right here. My E and my K is all along. So look at negative 2, and then I know my shape is go over 1, up 1, and the other one is go over 4. And let's try to look. This up here. Right there. So same 3 letters between the whole here. H, the horizontal. K, the horizontal. A is my what? Here. Same thing over and over again. Right? You always have a minus sign, so that's equal to 0. That's equal to 0 to the 0. That's factor, right? You know what that does? Okay, now that I say that, let's do this. So let's go over 1, 2, 3, and down 1, 2, 3, 4. 1, 2, 3, and 1, 2, 3, 4. I'm going to go over, up, and down, 1, 2, 3, 4. So, how much did I go over my horizontal? 3. I want to say, what would this look like if I were to take it inverse? Watch this. So this function right here, my pink one, is let's see, if we're going over 1, 2, 3, and then over 3, isn't that x minus 3? 3, and then what? Down 1, 2, 3, 4? Correct? So that's plus 4. Right? So what would that look like if I took it inverse? It would curve in the other direction. So it looks like this. It would, but I'm going to show you something. Let's forget about this first. No, you'll see what I mean in just 1 second. If it were like this, and then it would be over 2 and up 1, 2, 3, 4, correct? You see that? Doesn't that look like top of a parabola? Wouldn't that parabola be this? So you guys already know how to do this. You just take your vertex and go over 3 and down 4, right? We're doing the exact same thing, but since it looks like this, with the square root on it, instead of going this way, it goes. Okay, I just want to show that to you. All right, so now I want you to investigate the rest of these. So do you guys notice that there are no vertical and horizontal shift functions? For instance, this one is 4 times the square root of x minus 0. There's no horizontal shift, and there is no vertical shift. Okay, so as you're putting these things here, try and predict what they're going to do. So I'm going to give you about 3 minutes. All right, let's discuss our findings. So your parent graph should have been at 0, 0. And when you put 1 in, so square root, you just get 1, you get 4. So before we went over 1 up 1, but now we scaling it up to 4. Now the new prediction here. Not really it's a plus 3, right? Okay. Normally I went over 1 up 1, and the next point I put in is 4, right? I go over 4, and I go up how many? Yeah. The first one we go over 1 up 1 on the original graph, and then we go over 4 up 2. The first one we went over 1 up 1, the second one we went over 4 up 2. Right? Okay. Because the square root, right, if this was y equals, if I put in 4, I get 2. Right? Okay. There's too much talking behind me. I'm trying to make sure technical topic. So this time I'm not going over 1 up 1, I'm going over 1 up 4. So these things are not going to go over 4. Really? Is it like that? 8? Good. Okay, because it makes sense, right? This time, guys. The original paragraph was here, over 1 up 1, then over 4 up 2, like that. So this one, scale by 4, is over 1. Over 1 up 4, and I go over 4. I didn't go up 4, then it goes back. Let's double check. Let's double check the 4 here. Now the square root of 4 is just 2 equals 8. Let's try another one. This one, I'm not shifting horizontally or vertically, so I'm starting here. This one I don't go over 1 up 1, that's my parent graph, and I don't go over 1 up 4, I only go over 1 up 2. But why? So what should this really look like? I should see everybody looking up here going, what is she going to give us next? I want everybody to look at this and tell me, without plotting points, just looking at it, why am I only going up 2 and not 4? Because the square root of 4 is 2. Very good. Privately. Oh, yeah. Okay. We're as a class. Okay. Thanks so much. Okay. All right. So here's the $1 million question. You ready? So if I put in 4 this time, I'm not going to go up 2. I'm not going to go up 8. I'm going to go up 4. Twice as much as I would have before. Right? Before I would go over 4 up 2. For the one that was scaled 4, I went over 4 up 8 because it was 4 times 2. Now it's 2 times 2, so it's 4. What do we do if we don't know? What if we do if we're not sure? Substitute in. So if I substitute in 4, I get, which equals 4. Over 4 up 4. Okay, what happened here? What happened with number 7? There's a negative on the outside. It's the same shape, so it starts at 0, 0. It's got a scale factor of 4, so instead of going over 1 up 4, I went over 1 down 4. So when I go all the way over to 4, how far am I going to go down? Oh, sorry, because it's on the inside. Thank you. Down 2. So if I go over 4, then how far am I going to go down? 4. Okay, so this is how we remember this. This one, the only difference between this one and this one, number 6 and number 7, is that there's a negative on the outside. If I were to ask you this, if I was trying to solve for, let's see, if I was trying to solve for this, I would take the square root, right? Wouldn't it be y equals plus or minus the square root of x? Right? You guys have seen that before, because we don't know what the square is. We don't know whether it's positive or negative. It would be plus or minus x, right? Well, technically, we do have plus or minus x here. Technically, it is a parabola turned on its side, but it's not a function because it wouldn't pass the vertical line test, so we only take the positive one. So this one technically is the positive version. And this one is the negative version. Does that make sense? This is the positive side of the parabola. This is the negative side of the sideways parabola. Right? But what happens with this one? Same spot. We're starting at 0, 0. But this time, instead of going over 1 up 2, we're going over left 1 and up 2. And over left 4 and up 4. I should really be changing this. This is f of x equals 2 times the square root. And this one is, it makes it match better, right? This one is f of x equals negative 2 square root of x. Okay, so this one, it looks exactly like the green one, only it's turned in the negative direction. But if you pay attention to the signs, there's a negative on the x. So we're talking about not the positive x's when we plug in, but the negative x's when we plug in. It's a reflection, exactly, of number 6. And this one is also a reflection, but it's a reflection over the x-axis. This one's a reflection over the y-axis. Totally. Connections all over the place. And if you ever second guess yourself, what should you do? Substitute in a point. So if I wanted to check to make sure I am indeed going to the left, I could substitute in -1 for x. Let's try it. If I put in -1, square root, negative times -1, don't I get +1, which is just 2? So -1, +2, it does indeed work. Thumbs up, thumbs down. How are we doing? I have one more thing to show you. This has been fantastic. We're doing good. I think you guys could do, oh, what about this one? What's different about that one? It's got a 4x. I don't want to know about 4x's. What do I want to know about? 1x, right? We don't talk about 4x's in this graph. We talk about 1x. So if I'm only talking about 1x, shouldn't I technically factor that out? A 4. So if I factored out a 4, I'd be left with x plus 3 minus 2. And doesn't that 4, can't that come out of the radical sign now? Because I couldn't, because I had to factor it away from the 12. So now when I simplify that, right, isn't that a 2? And then I'm left with x plus 3 minus 2. So my vertical stretch, I'm stretching by 2. I'm going up 2. My horizontal translation is -3, or to the, I should say, to the left 3. And my vertical translation is what? Down 2. Okay. That one I had to cover, and there's one more thing I want to show you, and then you guys are going to be ready for your homework. So since I know all of this now, I can graph it. So my horizontal translation is to the left 3, 1, 2, 3. My vertical translation is down 2. There's my vertex. And my vertical stretch is over 1, up 2, and then over 4. 1, 2, 3, 4. And how much? 1, 2, 3, 4. And if you don't know that, you should check. Let's try it in reverse. This is in reverse. So let's ask ourselves, what is my horizontal translation? How much am I going on my horizon? 1, 2, 3. We went 3 in this direction. What does that mean when we put that in the equation? What should that look like? X minus 3. Vertically. How far am I going vertically? Up 2. Up 2, what does that look like on my equation? Plus 2. So now, all I need is my vertical stretch. Here's 0, 0. I'm over 1 and up 3, so how much is my stretch? A stretch of 3. So here's my equation. F of x equals a stretch of 3, square root, Gloria Bella, Parsa, x minus 3 plus 2. So if you can do it in reverse, you can do it in forward. One more, a little bit tougher. Visualize it for a second, and then I'm going to do it. some of you might not have gotten that, and this is why. Please don't touch the folders. Your horizontal translation is over 2, right? No, it's not 2. It is 1. Look how far we went over. We went over 1. So we went to the left 1. When I go to the left 1, that means x plus 1. Right? So you guys are probably confused with that. My vertical translation is down 2, so I had forgotten that. So that's negative 2. My stretch is by 2, so we have a vertical stretch, but then we were going in the negative direction on x. It should be this. You see how these two are the same? All I did was distribute the negative in. No, because a negative x times a negative 1 is negative 1. So if you see something like this, you've got to factor a negative out to make it look like this. Just like you had to factor this out. You guys don't go anywhere. Just like on this one, we had to factor out a 4. Well, if it's a negative sign, negative x minus 3. It's really negative x plus 3. It would be, yes, exactly. You got it? Okay, good job, guys.